On July 1st, 2025, telescopes belonging to a NASA-funded asteroid tracking survey in Chile picked up a faint, fast-moving object cutting across the sky, moving on a path so steep and so fast that it could only mean one thing. Whatever this object was, it hadn't come from anywhere inside our solar system. It was a visitor from another star entirely, only the third confirmed interstellar object ever detected passing through our cosmic neighborhood. Scientists named it 3I/Atlas. And in the months since that first detection, as telescope after telescope turned to study it, this ancient traveler from another solar system started doing something that comets from our own solar system essentially never do, something that has left even the world's leading cometary scientists genuinely searching for a complete explanation. This is the real documented story of 3I/Atlas, using nothing but published peer-reviewed observations from Hubble, the James Webb Space Telescope, and observatories around the world, and I promise you the true version of this story is stranger and considerably more interesting than anything you'd need to invent. Every date, measurement, and quote in this video comes directly from that published research. Not speculation, not exaggeration. Let's start with exactly what 3I/Atlas is, and why its very existence is significant regardless of anything strange it eventually did. Objects that pass through our solar system on a hyperbolic trajectory, meaning a path curved just enough that the sun's gravity can never actually capture them into orbit, are exceptionally rare. Before 3I/Atlas, astronomers had only ever confirmed two others. The strange, elongated object called Oumuamua in 2017, which tumbled through our solar system without displaying any visible cometary activity at all, and a genuine active comet named 2I/Borisov in 2019, discovered by an amateur astronomer using a homemade telescope. Finding a third interstellar visitor, and one large enough and active enough to actually study in real detail, gave scientists an almost unprecedented opportunity. A real physical sample of material that formed around an entirely different star, drifting directly through our own cosmic backyard. Follow-up observations eventually pinned down the size of its nucleus at roughly 2.5 kilometers across, making it noticeably larger and more massive than 2I/Borisov, the previous interstellar comet, giving astronomers considerably more material and activity to actually observe as it swept toward and eventually around the sun. Some early estimates, based on limited data, had even suggested its core could measure up to 5 kilometers across, which would have made it one of the largest interstellar bodies ever recorded, though more refined measurements gathered as observations continued eventually settled on the smaller, though still substantial, figure. The first genuinely strange observation came remarkably early, within weeks of the object's initial discovery. On July 21st, 2025, the Hubble Space Telescope captured detailed images of 3I/Atlas, and when astronomers examined the glow surrounding its nucleus, they noticed something that didn't match ordinary cometary behavior at all. Comets, as they approach the sun, typically develop a visible tail streaming away from the sun, made of gas and dust pushed outward by solar radiation and the pressure of the solar wind. The same basic physics behind why a comet's tail always points away from the sun, regardless of which direction the E. Comet itself happens to be traveling, a rule so consistent that comet tails have been used as a directional indicator by astronomers for centuries. But the glow around 3I/Atlas extended noticeably farther in the opposite direction, toward the sun rather than away from it, a feature astronomers call an antitail. Antitails aren't entirely unheard of. Some comets originating from within our own solar system have displayed similar features before, typically explained as a kind of optical illusion caused by larger, heavier dust particles lagging behind in a comet's orbital path in a way that happens to appear sunward from Earth's specific viewing angle at certain times, essentially a trick of perspective rather than a genuine physical structure pointing toward the sun. What made this different, and what caught researchers' attention immediately, was that follow-up analysis suggested this wasn't simply a trick of geometry. It appeared to be a real physical jet of material, genuinely extending toward the sun roughly 11.5 times longer than it was wide, once researchers accounted for the actual viewing angle involved. And researchers writing in a paper analyzing the phenomenon noted plainly that this behavior had possibly never been observed before on any comet, let alone an interstellar one. As more observatories around the world turned their attention to 3I/Atlas through the second half of 2025, the picture only grew more detailed and more genuinely puzzling. Researchers using a robotic telescope at the Teide Observatory in the Canary Islands tracked the comet across 37 separate nights between early July and early September of 2025, and documented something scientists were describing, in their own published research, as wobbling jets, streams of material erupting from the comet's surface that shifted and oscillated over time rather than remaining fixed in a single, stable direction, as if the entire structure of outgassing activity were slowly rotating or precessing as the comet itself tumbled through space. The research team behind that study noted directly that while wobbling jets have occasionally been observed in anti-tails from comets native to our own solar system, this marked the first time this specific kind of outgassing behavior had ever been documented on a confirmed interstellar object, giving scientists what they described as a genuinely rare opportunity to study the physical behavior of a pristine body that actually formed around a completely different star, untouched by billions of years of exposure to our own sun the way every native solar system comet has been. By January of 2026, using new higher resolution imaging from Hubble, researchers applying specialized image processing techniques, specifically a method called a Larsen-Cecchinina rotational gradient filter, designed to strip away the symmetric, uniform glow surrounding a comet's nucleus and reveal finer structural detail underneath, identified something even more structured, a distinct triple jet pattern emanating from the comet's nucleus, including one prominent jet extending sunward to a scale roughly comparable to the entire distance between the Earth and the Moon. And then, in an almost eerie bit of celestial timing, on January 22nd, 2026, 3I/Atlas align nearly perfectly with the Sun-Earth axis, drifting to within just 0.69 degrees of that precise line, a moment when its unusual anti-tail happened to be pointing almost directly back toward Earth itself, a coincidence of orbital geometry that gave astronomers an unusually clear, direct view of the very feature they'd been trying to understand for months. Perhaps the single most scientifically significant discovery came in December of 2025, when the James Webb Space Telescope turned its infrared instruments toward the comet and made a robust, confirmed detection of methane gas within its surrounding coma, the cloud of gas and dust that forms around an active comet's nucleus as it warms near the sun. Methane is what scientists call a hypervolatile ice, meaning it sublimates, converting directly from solid to gas at extremely low temperatures, colder than most other cometary ices, typically among the very first materials to vaporize as a comet begins warming during its approach to the sun. What made this detection genuinely puzzling wasn't simply finding methane at all, but exactly when researchers found it. The gas only became clearly detectable after the comet had already spent considerable time warming as it approached the sun, rather than appearing early in its approach, the way you might expect from a substance that vaporizes so easily under normal circumstances. Researchers interpreted this delayed appearance as evidence of a layered internal structure, suggesting the comet's methane ice sits buried beneath an outer crust of less volatile material, only becoming exposed and able to vaporize once enough of that outer layer had already eroded away during the comet's approach, essentially peeling back like layers of an onion as solar heating slowly stripped away each successive shell. Combined with unusually high levels of carbon dioxide also detected in its coma, researchers concluded that 3I/Atlas likely formed under genuinely different chemical conditions than anything found in our own solar system's protoplanetary disk, a real physical sample of alien planetary chemistry passing directly through our own cosmic neighborhood, offering scientists a genuine window into how planetary building blocks might assemble themselves around stars entirely unlike our own. Now, I want to address something directly because it's become a significant part of the public conversation surrounding this object, and I think it deserves a fair, honest treatment rather than either dismissal or exaggeration. Harvard astronomer Avi Loeb, a scientist well known for previously suggesting that Oumuamua, the very first confirmed interstellar object, might have been an artificial artifact rather than a natural comet or asteroid, has published extensively on 3I/Atlas as well, compiling a running list of what he describes as its unusual or anomalous properties. At one point, cataloging as many as 22 separate features he considers worth close scrutiny, and repeatedly raising the possibility that at least some of its behavior could theoretically be consistent with artificial technology rather than purely natural cometary activity. Loeb is a genuine credentialed astrophysicist, formerly the chair of Harvard's astronomy department, and he's entitled to raise these questions as part of legitimate scientific inquiry, arguing consistently that unusual anomalies deserve careful investigation rather than automatic dismissal. But it's important to be clear about where the broader scientific community actually stands on this. A global array of telescopes and spacecraft studying 3I/Atlas independently across the second half of 2025 and into 2026, including a radio observation from South Africa's Meerkat Array that detected only steady, ordinary background emission typical of gas and dust, rather than any structured, modulated signal that might suggest deliberate transmission, has consistently confirmed the object's natural origin. NASA itself unveiled detailed images of the comet captured during its close flyby of Mars in early October of 2025, gathered using spacecraft already stationed at the Red Planet, adding yet another independent data source to the overall picture. The consensus among the researchers who have actually published peer-reviewed analyses of its jets, its chemistry, and its trajectory is that 3I/Atlas is exactly what it appears to be. A genuine active interstellar comet, exhibiting rare but ultimately natural behavior that we simply haven't had the opportunity to study this closely before, because we've never had an interstellar comet this large, this active, and this well-observed pass through our solar system. That distinction actually matters, because I think the real story here is more compelling than an unconfirmed speculative alternative. What makes 3I/Atlas genuinely remarkable isn't that it might be artificial. It's that it's a real physical piece of another solar system, one that formed under different chemical conditions, around a different star, potentially billions of years before our own solar system even existed, and it happened to drift close enough for humanity's best telescopes to study it in unprecedented detail. Its unusual jets, its layered internal structure, its rare sunward anti-tail, these are genuine scientific puzzles, phenomena that don't perfectly match anything astronomers have documented in comets, native to our own solar system. But puzzling doesn't mean impossible to explain through ordinary physics. It means we're looking at genuinely new data from a genuinely rare kind of object, and scientists are doing exactly what they should be doing with it, publishing careful, methodical research rather than jumping to the most dramatic possible conclusion. By March of 2026, 3I/Atlas had already begun fading as it moved farther from the Sun, making its closest approach to Jupiter on March 16th before continuing on its outward journey, heading back out of our solar system along a path that mirrors, in reverse, almost exactly how it arrived. Aside from small deviations caused by the very same jet activity that made it so interesting to study in the first place, it won't be coming back. Objects on hyperbolic trajectories like this one pass through a solar system exactly once, using our sun's gravity for nothing more than a brief, one-time flyby before continuing on into the vast emptiness between the stars, never to return. So here's what I actually want you to take away from all of this. 3I/Atlas is a real, extraordinary object, only the third confirmed interstellar visitor ever documented, and easily the most thoroughly studied one to date. It genuinely displayed jet behavior that scientists had never previously observed on any interstellar object. A rare anti-tail pointing sunward, wobbling, shifting outgassing patterns, and a delayed release of methane, suggesting a complex, layered internal structure built under alien chemical conditions. Those are real, documented, published anomalies actively being studied by researchers around the world right now. What they are not, according to the overwhelming weight of actual peer-reviewed evidence gathered by multiple independent telescopes, is any kind of confirmed artificial technology. There's something arguably more valuable than that, a genuine physical window into how comets form around other stars, delivered directly to our own cosmic doorstep, studied in more detail than any interstellar object before it, and now already on its way back out into the dark, carrying whatever remaining secrets its jets and chemistry haven't yet fully revealed. There's something worth appreciating in just how quickly this entire body of research came together. From first detection in July of 2025 to a robust methane confirmation from Webb only 5 months later, to a detailed triple-jet structural analysis within half a year of discovery, this represents one of the fastest, most thorough scientific characterizations of any interstellar object in history, made possible only because multiple major observatories, an international network of ground-based telescopes, and even spacecraft already stationed elsewhere in the solar system were all able to turn their attention to the same target within a genuinely narrow window of opportunity, before the comet faded back into the interstellar dark it came from. If you want to know what scientists eventually determine caused those unusual sunward jets, subscribe and turn on notifications, because research on this object's archived data is going to continue for years, long after 3I/Atlas itself has faded completely from view. And drop a comment telling me whether you think its strange behavior gets a clean, ordinary explanation, or whether some genuine mystery remains even after all this analysis, because honestly, after everything astronomers have already documented about this object, I don't think the full story is finished being told just yet.